How do things work anyway? Are we just like are we just here? Or is there anything going on at all?
Of course there is!
Uh, uh, who are you?
Eudoxus!
A what?
Eudoxus!
Eudoxus was a Greek mathematician and astronomer born in Cnidus, Asia Minor, between the years 395 to 390 BCE and died between 342 to 337 BCE. He contributed to the identification of constellations leading to the development of observational astronomy in the Greek world, and established the first sophisticated geometrical model of celestial motion. Although none of his writings survived, he contributed to the philosophical discussions in Plato's Academy, and his contributions are still well known from many discussions throughout antiquity. He initially studied medicine with Philesion of Locri and mathematics with Archytas of Tarentum. At the age of 23, he attended lectures in Athens for 2 months before going to Egypt to study with priests. He earned his income by living as teacher and later returned to Athens, associating himself with Plato's Academy. Eventually, he returned to his native Cnidus, where he became a legislator and continued his research until his death at age 53.
To make a response to Plato, Eudoxus examined the motion of the spheres inside the solar system and came up with a theory he named the mathematical model of the solar system. This model illustrates that the Earth is the center of the 27 other rotating sphere series. Eudoxus gave each rotating sphere a unique rotation by giving it a different orientation. Spheres move in their own peculiar ways with varied directions. Each of the 5 planets was carried by 4 interacting spheres. The Sun and Moon were both carried by 3 interacting spheres, and the outermost sphere is made up of fixed stars. Since man has always believed that the heavens are divine and that God created man, the earth must be at the center of the universe, according to geocentrism. Around 380 BC, Eudoxus devised a plan based on the conviction to develop the first geocentric model of the universe. According to this belief, the earth serves as the center around which the sun, moon, and stars are created. Unfortunately, the Greeks rejected this theory because they thought it was inaccurate for measuring the motion of the other planets, and instead, they focused on studying the motion of the sun, moon, and stars.
Eudoxus was an ancient Greek astronomer and mathematician who proposed a geocentric model of the universe based on 5 principles, which include the following. First is that the universe is finite and spherical. Second, the earth is at the center of the universe. Third is that all celestial motions is circular. The fourth, the motions of the celestial bodies can be explained by combining circular motions. And lastly, the distances between the spheres determine the periods of motion. Eudoxus' model was an important development in ancient astronomy, and influenced later models of the universe, such as those proposed by Aristotle and Ptolemy. However, the model was later replaced by the heliocentric model proposed by Copernicus, which placed the Sun at the center of the solar system instead of the Earth.
Eudoxus was a prominent Greek mathematician who lived in 4th century BC. One of his notable contributions was a method of exhaustion which he used to find areas and volumes of curved shapes. The method of exhaustion was a precursor to the modern calculus and is still used today in some fields of mathematics. Furthermore, Eudoxus' work on proportion and ratio has had lasting effect on mathematics and science. His theory of proportion provided the foundation for the development of the theory of numbers, and his work on ratio is still used in many areas of science and engineering today, such as designing gear systems and calculating gear ratio.
Woo, hooray! Eudoxus! Okay, now I can sleep now. I'm finally done editing this
Hoy,
video.
Jen.
No!
Tycho Brahe was a Danish astronomer born on December 14, 1546, at Knudstrup, Scania, in the country of Denmark, who contributed his work in developing astronomical instruments and in measuring and fixing the positions of stars, paved the way for future discoveries. His study, as precise as possible before the invention of the telescope, included a complete study of the solar system and accurate positions of more than 777 fixed stars.
Tycho Brahe observed the supernova of 1572 and proved that it was a distant object, as opposed to an atmospheric object, as most scientists believed at the time. This discovery disproved Aristotle's 1,800-year-old theory that the heavens were unchanging. Brahe also proved that comets were not atmospheric phenomena, disproving another one of Aristotle's theory. He coined the term nova, meaning new. Initially, this star appeared as a bright object in the sky. This made Brahe find more on its parallax shift. A parallax shift is an apparent change in the position of an object against a background when viewed from two locations. Therefore, the parallax shift of this new object would be smaller if it was farther from the moon, or larger if the object was closer to the moon. However, Tycho did not observe any shift from the new object, and thus named it a new star. He described it as a fixed star that existed in the eighth sphere. Tycho Brahe was also the first European to build a mural quadrant, a 2-meter-long brass semicircle mounted on the wall that he used to measure the declinations of the stars. Brahe also invented his own versions of the wooden quadrant and the frame sextant.
Tycho Brahe devised a model wherein all the planets orbited the Sun, while the Sun and Moon orbited the Earth. He additionally proposed a theory in which contained both Ptolemaic and Copernican systems. He discovered the Tychonic system, which is essentially a geoheliocentric model. As a result, this theory is also known as the geoheliocentric model of the cosmos, simply because it is a combination of the two. Tycho was a firm believer of Ptolemy's geocentrism and Copernicus' heliocentrism. In other words, Tycho's model maintains the traditional Aristotelian concept that the Earth, which is stationary, is the center of the universe, with the Sun and Moon revolving around it. On the other hand, Tycho maintains the current Copernican belief that all other planets in our solar system revolve around the Sun.
Since his theories regarding the supernova and the parallax shift, and his devised model named the Tychonic model, Tycho's observations, in a way, contributed to the well-known theory of gravity of Isaac Newton. This is because Johannes Kepler's discoveries, which then gave Newton the clues to establish universal inverse square gravitation, was based on Tycho Brahe's discoveries. Moreover, Tycho was also the first to utilize the telescope to make extensive astronomical observations. This action, pioneered by Tycho Brahe, is still used in this day and age by astronomers to observe the planets, stars, and the outer space. Apart from his scientific discoveries and observations, the story and experiences of Tycho Brahe can also serve as a life lesson to us people. Brahe disapproving a 1,800-year-old theory just goes to show that there is no limit to curiosity. The universe is a vast place, and surely there are still amazing things waiting to be discovered by you and me.